This is Adi, and you're listening to the Summer of Bitcoin Experience. In this episode, we talk to Krystal Maughan, a student researcher at the University of Vermont, United States. Krystal participated in Summer of Bitcoin 2022 with René Pickhardt on quantifying the robustness of the Lightning Network and empirically understand its routing constraints, which we go deep into in this podcast. Krystal also shares her experience working on open source and advice on how should one go about it. Now, on to my conversation with Krystal. Hope you enjoy it. Hey, Krystal, welcome to the Summer of Bitcoin Experience. Great to have you.
It's great to be here. Thank you so much, Addy.
Let's start with your introduction. Can you tell the audience, who you are and where you come from?
Sure. So I'm originally from Trinidad and Tobago, which is in the Caribbean, and I did my undergrad in Ithaca in upstate New York, and now I'm a PhD student at the University of Vermont.
Awesome. And what is your PhD about? What research areas do you look into?
So I originally started my PhD working in particularly machine learning, so interpretability, which means that I'm looking at, well, in one particular project that was long-term, we looked at this mechanism called prediction sensitivity, which allowed us to look at gradients and prediction. So if you have a point that has a particular gradient and you look at a flipped prediction, so let's say you have a binary variable or what do we call protected attributes. So something, let's say someone is male in that particular data point, and we were to switch it to female. If we have an algorithm that predicts significantly different from the prior prediction, we might want to say that there's something wrong with the algorithm, or we might want to look into the algorithm. And this is a specific, really useful mechanism that could be used for high stakes auditing of algorithms. So that was kind of a project that I worked on in my first 2 years. Now I shifted, well, actually a couple from around 2021, I shifted to working on isogeny-based cryptography. And isogeny-based cryptography starts off with the premise that in the future, we will have quantum computers. And quantum computers, unfortunately, unlike classical computers, are able to make are able to kind of break some of our current encryption systems, because some of our current encryption systems rely on this thing called the discrete log problem, or DLP for short. And so that means that a lot of our authentication systems and maybe things that we use to authenticate browsers, check our bank balances, that sort of thing, will be rendered insecure. So post-quantum cryptography, which NIST, which is the National Standards Committee for these kinds of protocols, had a call in 2017 to look at protocols that might be quantum safe, and isogeny-based cryptography is one such protocol. And so that particular protocol is based on a specific pairing of elliptic curves called isogeny. So it's called a morphism map between two elliptic curves. And that allows you to create this thing called an expander graph, which, because of its hardness of pathfinding, makes it quantum safe. So a lot of cryptography protocols in general have some kind of hardness property. Unfortunately, that doesn't necessarily make them quantum safe, but in this particular case, isogeny-based cryptography should be quantum safe. So that's something that I'm working on right now for my dissertation.
Wow, that's quite interesting. All right. I want to talk about Bitcoin today, of course, since it's the
Yes.
Summer of Bitcoin Experience. Before we get into your project on Bitcoin last year, maybe I'm curious to know, when was sort of the first time you heard about Bitcoin?
So interestingly, the first time I heard about Bitcoin was, so I lived in Los Angeles before I moved to grad school in Vermont. And I attended this conference, which was it's kind of a controversial conference, but I was really into functional programming, in particular this functional programming language called Haskell. And there's a conference called LambdaConf, which was organized, and I received a scholarship to attend in, I think, 2016 and 2017, if I recall. And through that, I was able to attend, these workshops on, Lambda calculus and using Haskell and that sort of thing. And in one particular year, every attendee received Bitcoin. So as long as you attended, they gifted you with some Bitcoin. So that was, I think, around 2016. And what was interesting is that on the way that they gave us the Bitcoin was from a company, I think called 21.co. And that eventually became this recruitment platform where recruiters would contact you and you could specify a rate at which you'd want to be paid for them to contact you in Bitcoin. So because I didn't know, and I was pretty new to development at that point in time, I just kind of said like, okay, I don't know, maybe like $1 worth of Bitcoin or something. And I was able to make some money from recruiters contacting me, and in Bitcoin. So that was my first interaction with Bitcoin.
Well, that's quite interesting. and and so you happen to basically receive Bitcoin in this setting for the first time, but what was your impression? Like, did you think about whether or not it meant anything?
So I had been, because I was anywhere in the kind of California, SoCal, NorCal area, it's very like a kind of techie scene in general. I was really thrilled. I knew it wasn't a lot of Bitcoin, but it was I was kind of fascinated by it. And I did have a couple friends who were into Bitcoin pretty early on. One of my friends, interestingly, as more people found out about it, was able to buy a house, which is interesting.
Wow.
But it's I think it was more. So the other thing about the functional programming community is that because of the language has various properties, those programming languages have things like types or certain constraints. They kind of were a good fit during that time when I was curious about and learning about Haskell and those kind of languages. Um, they had a good fit for crypto companies. So more companies like, say, Cardano and that sort of thing were actually at the conference trying to recruit. So I think in the context of that was kind of how I understood um, something about crypto. And well, of course, Bitcoin was like the most well known. But kind of in the context of like, okay, the languages that I'm learning, I could get a job at one of these companies if I learn this programming language, even though that wasn't my primary concern.
Interesting. So, what convinced you to pay attention? And when was this?
You mean in Bitcoin in general, or
Yeah. So, I mean, you
oh,
you happen to come across Bitcoin. It's obviously a thing that, some of your friends are involved in, and, obviously you come to interact with it in some setting at the conference. But, Bitcoin has this larger appeal to a lot of people in terms of what it is trying to be in the society we are in. It's trying to be money, and then it's also technology that is solving some really interesting um, unsolved problems in computer science, in distributed systems and so on. So around those aspects, when was the time when you sort of finally started to dig in and perhaps read a little bit more about it?
yeah, so I think it was a mix of a couple things. So one thing, of course, is my interest in cryptography. So I think I saw a talk. Oh, so I attended this. It was a summer camp at Cornell Tech has kind of a summer workshop hackathon where presenters talk about cryptocurrencies. I think it's called the Cryptocurrency Initiative. And I attended that one and I helped out on a project. And I think that was the first time, because the projects in particular, it was a hackathon and we received we were in the top four. They didn't have a first place, but that group is in it. The group that I was in was in top 4, and that particular project I thought it was interesting because they were looking at kind of evaluating in the same way that my initial research was focusing on explainability and say like algorithmic fairness. What does fairness mean in a distributed system? So what does it mean in terms of having evaluating the fairness in batch transactions or individual transactions? So when someone makes a transaction, say a party A, do you process their transaction in a batch, or do you process it as an individual in terms of they place it first based on a specific timestamp? And then the other thing that I was interested in was that I had taken a class during COVID at I've been part of the IEEE Information Theory Santa Clara meetup group since 2016. And they were offering during COVID a class online, like an opportunity to audit this class with a Stanford professor, David Say. And David Say is like really well known in information theory, and he's very into cryptocurrency, and he loves Bitcoin. And so his whole class is about understanding consensus protocols and scalability within protocols. And he talks about what the kind of the triad of security, having the period of time for a transaction and that sort of thing, and how those things make Bitcoin work. And we also went through a number of different protocols. So we went through Prism and all sorts of things. And I believe at one point we even had Chia. We had Brett from Chia give a talk. And that was, I mean, it was just an incredible class. And I think that kind of ignited my interest in finding out more, because I kind of realized, I moved beyond kind of understanding Bitcoin as this thing that was kind of a mechanism for things like remittances and people using it as a currency, and more so in terms of, oh, this is a consensus protocol, and these are the things that make it work in a particular way, and what will happen, kind of asking what will happen as this thing scales. What is the future? What is the longevity of Bitcoin?
Yeah. So let's switch gears to Summer of Bitcoin. How did Summer of Bitcoin fall on your radar, and what was that whole journey?
So again, I was looking for, kind of the intersection of something cryptography related because I was interested in that, but also Bitcoin related because I was looking into, scalability consensus mechanisms. And especially after the Cornell hackathon, and I had a really good experience with that and the Stanford class with David Say. And what I had realized too was that I really missed open source. So I've in the past I've taken part in Google Summer of Code. So I did that in Haskell. I've taken part in Mozilla had an opportunity to learn Rust called Increasing Rust's Reach. And I had just taken part in Microsoft Research has a program called Reinforcement Learning Open Source Fest, where you contribute to a reinforcement learning library in machine learning. So I had just done those in 2018 and in 2021. And I was kind of itching to get back into, being a part of and understanding the open source community again. And I don't know exactly how, but I guess I was just poking around and I saw it and I just thought, wow, this is an amazing program, and it just fits my needs so much. And so I just joined the server, and it's very intimidating because there are a lot of people on the server. But I eventually, I think, kind of finding the project that fits what you are interested in, and also realizing that within the channels you see certain people over and over, made it a lot easier to kind of deal with, and a lot of these open source programs have a lot of volume and noise, and sometimes it's hard to figure out, should I even apply? Because, are there just like too many people? But I think if you have an interesting question and you have an excitement to learn, it's definitely worth applying.
Yeah, that's beautifully put. So let's dive right into your Summer of Bitcoin project. You applied to work on research on Lightning Network with René Pickhardt.
Yes.
Um, do you want to maybe talk about why you chose that particular project with René?
Yes. So I actually didn't initially think like that project was not on my radar at all. I was again, I had been looking, I had so one of the things in I think it's important when you're choosing or looking at an open source contribution or when any of these programs is to kind of look at your strengths. So for the first open source program that I had done, I knew that I was pretty connected to the Haskell community and that it's kind of like a game, right? You're kind of trying to, I'm not saying gaming the system, but you want to maximize your odds. So I knew the people in that community, and I knew that not a lot of people would necessarily apply to Haskell because it's such a strange language, or not strange, but it's not taught in a lot of schools. So I would have pretty good odds of getting in. In the same way, I was looking initially at the Merkle tree project, because I thought, well, my strengths are cryptography. And then I came to one of your sessions, actually, Addie, where I had asked the question and I said, is there something that exists that's like this? And you had said, which I think is a great plug for coming to your info sessions as a student. But you had responded and said, oh no, this is an actual project. This is a thing. And then I looked at the project and I looked at the channel and saw that it was a research project. And I thought, well, this is it. If there's one project that I want to do and write a proposal for, I would definitely be interested in this one. And so once you had explained that this is the case, I had checked out the channel. I looked at the project, I looked at the papers. I thought this, I'm not necessarily an expert in all the parts, but in any case, this will be an opportunity for me to learn.
Sweet. So, I want to maybe start off before we sort of dive into the weeds of your project. If you could tell the audience at a high level, what is Lightning Network all about? And then, we could maybe drill into the specific areas that you worked on.
Okay. So Lightning Network on a high level. So I actually I give a talk on this over in fall, last fall, but it is off-chain. So when you think about blockchain as a network, there are these transactions that happen on chain and they take a certain amount of time to process, and they're usually, middle to large transactions. But maybe we want to be able to do smaller transactions that don't take as much time. So we would do these off-chain, not on-chain. And so the Lightning Network enables micropayments, which are smaller payments, to be processed quickly via these microtransactions off-chain. So that's kind of the premise. And the way I like to think about it is many of, well, the talk that I gave was that many, say, immigrants today in New York City, for example, have these kind of pop-up shops. And when you buy things, they don't want to pay the transaction fee, the processing transaction fee.
Mhm.
And in that case, maybe they're not making they're not trying to funnel through large transactions. So Lightning Network might be a really great solution to these kinds of transaction fees and minimizing that. And yeah, so and what it is too is it's a bidirectional payment system. So we think of a network as nodes and edges, and you can, if I have an individual A represented by a node and an individual B, A can send Satoshi to B and B can send Satoshi to A.
Yeah. And, when it comes to some of the scalability concerns around the Lightning Network, um, what are your thoughts? By itself, it awesomely scales Bitcoin to, many more transactions, but then there are sort of concerns or limitations, or there could be problems later, and when it's running at scale, and maybe channels, managing channels and liquidity across those channels is a problem. Could you maybe opine on that a bit? Let's take a quick break and hear about today's sponsor. Hey everyone, this is Adi. When I was starting in the Bitcoin industry a few years ago, there were hardly any resources to learn from. It was especially hard to find other like minded Bitcoin developers and discuss about building apps on the Bitcoin blockchain. Well, things have changed, and I'm so excited to share with you about the Build on L2 initiative. Build on L2 is a community led effort by contributors and companies building on Core Lightning and the Liquid network. It's a space to connect with Bitcoin builders, product managers, designers, and developers through events and mentorship programs and learn from experts building the future of Bitcoin. It's exactly what I wish I had when I was starting out in Bitcoin. Go to buildonl2.com to join the community and learn how to build killer apps on Bitcoin. Back to the show.
Sure. So I think honestly what René, Sebastian, and and a bit myself, what we're working on is important. I think that for example, um, the in my dissertation work, the protocol that I spoke about, the isotope-based cryptography, there was a huge attack last summer in about August 2022, and so parts of it are broken. In the same way, I think about the fact that we are evaluating robustness and there are concerns about Lightning Network, but for anything that is long lasting, it is better to do these kinds of evaluations on the network to look at the potential scalability, to look at the robustness. The worst thing would be, I think, especially coming from a research background, to tell everybody with optimism, oh yeah, this is great, everybody should just join, and then there are issues down the road. And I think that yes, you can say that there are issues, but every technology has kind of gone through some kind of iteration of from its initial um scale to growing. And I don't know, you kind of, it's part of growing a community in general, is that look at Twitter and Mastodon, and all these people migrated from Twitter to Mastodon on all these different servers, and they had a lot of, Mastodon initially had some issues with having timeouts with the number of people joining en masse. So I think within any kind of decentralized community, or certainly a network, these things have to be evaluated. I don't think it's necessarily like a negative, or like something that you'd say, oh, well, don't use something. I think it's really important when you have these kind of technologies to test them thoroughly, to make sure they're robust, to eventually have a lasting technology.
Yeah, for sure. So I think that's a perfect segue to the actual project that you did, which was around quantifying how robust the Lightning Network is. And tell us how you went about solving it. What did you find, and what were the results that maybe you would like to share with the audience?
Sure. So I want to say that a lot of this work was guided by René. I think René was a fantastic mentor. And so René, I think, had the initial intuition, which is why the project came about, that and this is based on probability theory. So if we look at the probability based on a smaller iteration, which is in mathematics or computer science, what you do is you start with a small case, and then you induct upon it, or you look at iteratively a larger case. So what he was saying is that if you looked at this smaller case and you scale it up, there's a high probability that a network would fail. And so our summer was spent kind of looking at how we could model that. And so some of the issues that came up initially were that when we look at models for these kinds of networks and these kinds of problems, we found a lot of kind of analogies to, or comparisons to, things like transportation system. So if you're on which I talk about in my presentation that I gave, if you're thinking of a road and you have, let's say you have a small road and there is a certain flow of traffic, say 1 lane traffic, and all of a sudden people realize that this road has less traffic than, say, another road to get to the same place. Maybe people will decide to use this other road. But what if everybody decides to use this other road that was meant for 1 lane traffic, and now it's jammed with like 6 lanes? How does that scale? And so we're looking at those. We're looking at some other things involving some like even physics properties with Brownian motion. So all kinds of models. And the thing that we kind of settled on, which I think was in research, the way René saw it was that, yes, we could show this directly with probability theory and with a simulation, but let's look to see if there's something in the literature that has a similar mechanism. And it was really challenging because a lot of, when you look at things like network, like traffic network, which I mean in terms of internet traffic and network routing, what they usually assume is that the traffic is going in a particular direction, or it doesn't assume that, in our case, that the nodes can be bidirectional. We also have this added complexity where, which I think Sebastian is working on, called multi-part payments, where in order for a payment to go through, it has to go through on every single node in the network. So there are all these kinds of ways that we can have what we call flow through the system that is bidirectional. And so that was a very difficult and novel thing to kind of find in the literature, something similar. And so the closest thing we found was this kind of game theoretic constraints called congestion games, which interestingly I've seen used for things like NASA telescopes, not NASA satellites, sorry, which is interesting. But so eventually that was kind of the conclusion that we came to, as well as starting with an initial, A versus B. So A pays B and B pays A. And we modeled that as something called payoff, this payoff diagram or payoff table, which also comes from like game theory and probability theory. And but this is over a graph. So there's this added complexity of, okay, these things are connected. And what happens if we lose a connection? And so I had taken a random probabilistic graphs class. And one of the first things I thought about is this, it's like percolation theory and something called Galton-Watson, where you have this equal probability of a node and an edge, or an edge being connected to another node. So we have 2 nodes. There's a 50% chance that they're connected, which could represent the situation where you're sending a payment from one node to the other. However, that doesn't necessarily account for the bidirectional aspect, which is not just A being connected to B, but B being connected to A. And this is important because when you're thinking about flow in the particular case of the Lightning Network, it is bidirectional. So it's not in typical network flow graphs where you're just thinking of, they call them directed graphs, which assume one direction. It is also bidirectional. And so those are some of the things that we kind of had to dig deep into the literature to find.
Interesting. So could you talk about how you extended, this example of the flow between just 2 nodes to perhaps the entire Lightning Network, and maybe determining, the robustness for the entire network using, probability distributions?
So the probability distributions started with René. I think I will give René credit for this. Absolutely. And what that started with is, if we have that payoff matrix where we have, if we have a node A and a node B in a network sending, so we don't want to think about the other parts of the network, just A paying B and B paying A. And they each have 1 Satoshi each. So at any given time, there's a 50% probability that A can pay B or B can pay A. If we graph that over time, then we should expect what we call a normal distribution, because we have an equal likelihood of either A paying B or B paying A. But what happens if we have one that has a higher probability than the other? It starts to look like a skewed graph. So the skewness we kind of or René rather typified as a drain. And so this drain would increase over time as we had a higher probability of one individual paying or having a higher probability of paying the other more. And if we look at that as typifying a network where you can have, we call it selfish routing, where one particular node is more likely to have flow in its direction. And we extend that idea of this flow in this direction in the context of that same original road that I was talking about. So we think about that flow and that node as, say, representing congestion on a road, and everybody deciding, okay, let's just jump to this road to travel. We could think about that in terms of a payment system where at any given time to make a payment on a network, maybe the network chooses a particular path for nodes, and that particular path gets used over and over. But if that's because that has a higher likelihood, and we increase the scale of that, will that mean that the network will fail, or will there be failure on the network? And how does that mean? What does that mean in terms of the robustness of the entire network? So that was kind of what we looked at, which again is this kind of inductive case. So we start with a smaller case, which is the two-party A and B. We scale it, and we also, and then we kind of grow it to include what might happen for an entire network.
Nice. And so, by modeling this sort of a congestion in the Lightning Network, you can essentially figure out what's the best state for equilibrium, right?
Yes, exactly.
Where we don't run into these liquidity issues in the Lightning Network. Could you tell us about that equilibrium state? What did we find around it?
So that one, so the equilibrium in particular was part of that finding of congestion games. And so this originally we were thinking of, it was Carger's work. I can't exactly remember, but it was essentially like a Nash equilibrium. And so we were trying to find something that might give us, because what we're saying essentially is that for every game, when you're modeling a game in game theory, you need to have, it needs to terminate. And that termination is usually represented by some state of equilibrium. And so we had to find the right game that would give us this particular termination. And so for that, I was looking at a lot of work on Brouwer's fixed point theorem. So Brouwer's fixed point theorem talks, it's like based on Brownian motion in physics, where you have at some point, it's like a fixed point is, how do I explain it? It's like, it returns itself. So there's this kind of, it doesn't, if you think of it as a, what do you call it? Like a convex optimization or auto differentiation, maybe that. You want it to kind of reach a minimum, or minima, sorry. And so in this case, our minima would be when that game terminates. And so we were looking for the right mechanism, which could explain when in our situation that game would terminate, and that turned out to be the Nash equilibrium in that particular congestion game that we found.
And in these sort of congestion games that you modeled on the Lightning Network, based on sort of the channels and liquidity among all of the nodes participating in the network, one of the parameters that affects the model or the graph or the network is obviously the fees that
Right.
that nodes essentially earn, or that is to be paid every time someone makes a payment through the Lightning Network. Tell us about the findings you had around how changing fees affects the network, and if that was the only parameter that makes a difference, or if there were other parameters that affects the congestion game as a whole.
Yes. So one of the things that actually pretty early on, René wrote a really great article on via BitMEX, where it was shown, with using that example of the drain in selfish routing that I spoke about earlier. It was discovered that fees, which are usually the parameter and cost function. So that's actually a great point. So in a lot of the models that we were looking at originally, it was assumed that cost was what we wanted to optimize. And so when you look at a lot of particularly economic models, say for like mechanism design, you're looking at things like I want to for example, if you have a number of stores and you want to maximize or a certain route and you want to maximize an optimal route, people usually converge on an answer, or they say like use convex optimization on cost, because it's usually assumed that cost is the thing that people want to maximize. And in this case, when the different variables or features were plotted, fees were not the only things to optimize liquidity. So it's interesting because that was another issue, I think, with kind of modeling the Lightning Network or thinking about the Lightning Network, is that the literature that we found, a lot of it that was initially kind of similar, focused a lot on optimization based on fees. So that meant that we couldn't necessarily use those direct models to think about the Lightning Network. So yeah, so in this particular graph, we had looked at like optimization of fees, optimizing uncertainty, and feature engineering of the combined cost. So kind of a mix model where it's a mix of both features, and to see what that would mean in terms of the expected drain of selfish routing. And so that also was kind of shocking.
Yeah. So it sounds like the Lightning Network is really unique as far as the existing research literature is concerned in terms of modeling these networks and figuring out what's the equilibrium state where we don't have as much congestion as as one would like to avoid. um
Yeah, I think that it's also one of those, in a lot of models too, I think, because I can't say for sure that we are the only people who've done work on Lightning Network. There's certainly, and we did find, when I was looking, I found other people. There's a mailing list that we were on, the Lightning Dev mailing list that René kind of suggested that we all join. And there were people who had written stuff up on the Lightning Network, but what René was saying is that it's really one of those systems that you need to understand as well, because you could be making false assumptions if you don't understand the way it works. So I think I want to say again that just having like René as a mentor who he really understands Lightning, um, is I learned a lot just from his saying, my going down a path and saying like, oh, isn't this kind of like this? And he's saying, no, 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 no. This is not a correct model, because if it's not a correct model, then your assumptions about features and parameters and optimization are just wrong.
yeah. So I guess to wrap it up on your project, how would you summarize the findings of your project, for someone like a layman or maybe even a developer who is now contributing to the Lightning Network? What should they think about when they are building for the Lightning Network?
That is actually an interesting question. I think that for someone who's building, I think maybe um, spend some time learning about the Lightning Network. Spend some time testing and doing some simulations. Like Sebastian was incredible and did a lot of work on kind of getting to know the network and simulating. I think that's also part of why he did so well. Like he really knew the system inside out. I think that provides insights. And I think it's a system. It's like every system. You have to learn the ins and outs of it. And also, I think what's important is to get to know the community. A lot of the time, people, I would say not just researchers, but people who want to build things, it doesn't help if you build things necessarily without understanding what the community needs. So being a part of the community is super helpful. I think that if I were to just have an independent researcher come along and tell me, hey, do you want to work on this project? And they didn't really know the Lightning Network, I think it would have gone completely off the rails. But having someone who's so core to the community, like he was giving talks and he has a connection with Chainlink and SF Bitcoin devs and all that sort of thing to really understand what the community needs is, I think it's kind of the sweet spot of working in particularly Bitcoin research or Lightning Network and that sort of thing. So that's the advice I would give is kind of immerse yourself as much as you can in the community and get to know the problems, the real problems that people are engaged with before just kind of assuming and jumping into a project.
Awesome. All right. So, I guess, to the one last question that I probably have about, um, the takeaways from your project is, I mean, you spent a couple of months working on Bitcoin. You had a fair idea about Bitcoin, before you even got started with Summer of Bitcoin, but then you were sort of in the weeds, talking not just to Renee, but perhaps reading a lot about how people use the Lightning Network and, sort of trying to model their behavior, trying to understand the robustness of the system. Um, were there any things that changed? Uh, was there anything that was different, in your understanding of Bitcoin after the summer? Then, of course, when you first, heard about it, when you first started with your project.
Definitely, I think one of the things that really kind of affected me that Renee speaks about is I thought of it coming in as kind of a distributed system, as a network. And I think afterwards I realized how much things like economic behavior are important in kind of thinking about those systems. And I also after the summer, I ended up taking a couple graph theory classes and now I'm working with a professor on a graph theory project as well. So I think kind of it it made me kind of open my eyes to maybe some of the ways that we could be thinking about crypto systems. So I mean, there's a lot more focus now because there's a community called the Economics and Computation Conference, which I'd kind of been in at the beginning of my PhD, kind of lingering about, but they've only now kind of started to include economics and computation cryptocurrency track in recent years. So at the beginning of my PhD, there was not one. And in particular, Tim Roughgarden, who works on these kinds of problems, had gave a keynote over the same summer that I did Summer of Bitcoin. So that kind of intersection of thinking about theoretical computer science questions and behavior in systems is, I think there's a lot of room for that kind of work. There's also a lot of room um, for understanding crypto systems itself and the system and concurrency and that sort of thing. So I think that after summer, I kind of realized that there's so much room for all kinds of work. And it really changed at the beginning of summer. I thought, okay, well, this is going to be open source coding kind of projects. So, but I think having Renee open my eyes to the fact that no, there are all these interesting questions in the community, and we do need different kinds of people with different backgrounds to work on them. That was something that I learned over the summer and through the program. And I think so I think that if a lot of students who think that they don't necessarily have X background, you'd be surprised by what you might be able to bring to a project, regardless of your background.
Yeah. So by now you've had quite a few experiences with open source, right? You previously participated in Haskell, in the Haskell community, and now with Bitcoin and Lightning Network. What advice would you give for anyone who is looking to contribute to open source, based on your experience so far?
So in contributing to open source, I think there's a lot of you can be it can be intimidating. I mean, in my case, I can see why someone might be hesitant or think that maybe they don't have enough experience. But I think that what helps you overcome that fear is, again, learning and being involved in the community. Like I would have never applied for Summer of Code for Haskell or any of those things if I hadn't met someone or a mentor who kind of encouraged me to apply. In the same way that if I hadn't gone to that conference and gotten Bitcoin out of serendipity, I might have never gone down that path. Or if I hadn't taken the class with David, say, and done especially the Cornell Tech hackathon, because the people were just like that group was just so nice. And even though I was pretty new, they just said, "Oh no, we can work together, or we can solve this." And then we ended up getting into the top 4 groups and presenting our work and that sort of thing. I think that can help overcome any kind of intimidation or hesitation. And I think that open source in general is a great way to kind of give back and be part of the community. So I don't know. I think that's kind of a big takeaway that I had, was that you feel like being part of open source, you feel more connected to the technology and to the community, just because like it is kind of a very personal thing, like when you contribute to a project, when you spend time on it, and when you especially know people from the community. So like, all of a sudden it's like, oh, René's giving a talk at SF Bitcoin devs, and I was like, oh, I know René, So I think that's kind of a lovely way to also stay engaged and to last, is to be part of a community, because a lot of like Summer of Code people or those kinds of people, sometimes they drop out, life happens. But the more important thing is, like, long term, you kind of are part of this community that you feel connected to by taking part in open source.
All right, Krystal, this was a fantastic conversation. Before we wrap it up, where can people find you and follow your work?
Oh, they can find me. So I have LinkedIn. You could search for me, blog. You can email me. Yeah, I'm usually pretty busy, so I'm going to be going off to a mathematics conference in about a week from now, on specifically elliptic curves stuff, cryptography stuff. But I feel free. I'm also in the Discord. So recently, some people have been asking me about my proposal, which I didn't really talk about in this interview, but I think I would also be happy to share my proposal if anybody's interested. I was good advice for proposals: be specific, know the project, have milestones. I learned that in Summer of Code. So have your specific milestones of what you want to accomplish, specific goals, timelines, your background. Make sure that you're the as much as you can, like the best suited in terms of contributing, and show like passion. And I guess good luck for those applying this year.
All right, Krystal, thank you so much for joining us today.
All right, have a good day. Thanks, Addy.
Thank you for listening to the Summer of Bitcoin experience. I would love to get your thoughts on what else would you like to hear from these student developers, and how to make this the most valuable podcast for getting started with Bitcoin open source development. Write to us at hello@summerofbitcoin.org. Can you do us a small favor? Go online and share this episode with at least one friend who you think would benefit from this episode. Until next time.